Welcome back, everyone. I have received messages of few students and they have demanded for statistics portions, that's biostats for the Pdcet exam, useful in both PDI and Gynae paper. So, this is part 3 of our pediatric revision series. Pdcet is on 12th and today is 10th, so only a day is left. So, let's go through this. Uh, I'm already saying that I have not prepared any detailed lecture or much calculation based lecture for statistics, but yeah, I'm trying to cover two important MCQ like questions so that you can get a basic idea of stats. So if you have not read stats so far, at least go through this video. You might get at least two or three questions from that topic. Okay. So first of all, types of data. Type of data. There are different types of data: qualitative, quantitative, discrete, and continuous. So qualitative data, also known as categorical data, and examples is gender and blood group. Qualitative means what, or categorical means what? It is qualitative or categorical means it's divided into various categories like category A, category B, category C. For example, they are uh, none of these categories having any overlapping features. For example, we see the example of gender, either male or female. There is no overlapping. Okay, blood group either A, B, AB or O. So there is no overlapping. It's either A or B or AB or O. Okay, so this comes under qualitative. It is yes or no sort of thing, categorical. Next is quantitative. It's numerical. An example is age and weight. For example, anything like which lies between 0 to any number, or any, if we say for percentage, then 0 to 100. Age can be any number, just newborn, or from 1 month, 1 year, 2 year, 10 year, 100 year. Okay, weight can also be 0 to 100 or 0 to 125. Any number can be there. Okay, so there is no exactly categories like yes or no, male or female, or any blood group. So this is quantitative. Discrete, number of children. Continuous, height and BP. Okay, so height and BP is continuous means and like height 90 centimeter, 91, 92, 93, 95 BP also. So this is continuous. So these are four types of data. Mostly important ones is qualitative and quantitative. You have to know difference between these two. Measure of central tendency. Three measurements for central tendency: mean, median, and mode. Mean is affected by outliers. Mean is what? Mean is sum of all the n, that is sum of n upon n. Like you, if you're having any five numbers, 4, 6, 7, 4, and 2. So how many numbers are there? Divided by n. So total is 4, 10, 17, 21, 23. 23 by 5. So 4.6 is the mean, and it is affected by outliers. Outliers means extremes. Like if there is a series of five numbers, if we take 1, 2, 3, 4, and 5. So the mean for these is 1 plus 2, 3, 3, 6, 10, and 15. 15 by 5 is 3. Okay. Now suppose the difference, these numbers are 1, 2, 4, 8, and 9. Then 1 plus 2, 3, 7, 15, and 24. 24 by 5, so it is 4.8. So it affects by outliers, means here 1 to 5, only the difference of 4 is there between the biggest number and the smallest number. Here the difference is 8. So it depends on outliers. Median is best for skewed data, means it's not the continuous data. So median is best variable, and mode the most frequent in a particular group. Like most frequent means uh, if there is data range 1, 2, 1, 4, 3, 1, 7, 1. Now, which number is coming most of the times? 1, 1, 1, 1. So out of 1, 2, 3, 4, 5, 6, 7, 8, 4 times we have seen 1. So the mode is the most frequent number. So 4 is mode here. In case of normal distribution, mean is equal to median equal to mode. So this is MCQ question. For normal distribution, they may give options like mean is equal to median equal to mode, mean more than median equal to mode, or mean less than median less than mode. Any sort of questions they can frame. So you should remember in normal distribution, mean equal to median equal to mode. Next is measures of dispersion. This was measure of central tendency. Now measures of dispersion: range maximum to minimum. Okay, like you have students in a class, and the weight of those students is minimum is 30 and maximum is 45. Class 6 student with minimum weight 30, 45. This is range. Variance is spread of data. No need to go in much detail, just try to remember this. Spread of data and standard deviation is the most used measure of dispersion. We usually take mean plus minus standard deviation. So standard deviation, we have different formulas for that. Now plus minus 1 standard deviation, we are covering 68%, plus minus 2 covering 95%, and plus minus 3 is covering 99.7%. Suppose this is the distribution of data, the Bell's curve we usually see. So this, the middle part is mean. Now mean plus minus 1 standard deviation means this is 1 standard deviation. Okay, 1 standard deviation minus and 1 standard deviation plus. So this part is covering how much? 68% of data. Now suppose mean plus minus 2 standard deviation. This is minus 2 SD and this is plus 2 SD. So this is more as compared to this one. So this is covering around 95% of the data values. And next, if we see minus 3 standard deviation, it is this side of the the mean line is negative, this side is positive. So minus 3 SD and this is plus 3 SD. So this is the largest column. So this is covering around 99.7%. So this can be asked in MCQ also. Plus minus 1 standard deviation, 68%, plus minus 2, 95%, plus minus 3, 99.7%. Okay. Now normal distribution, bell-shaped curve. For normal distribution, it's symmetrical, mean equal to median equal to mode. Okay, so this is bell-shaped curve for normal distribution of data. When skewed is right skew, like this is normal deviation, okay, and right skew is this is more skewed towards right side, and left skew is this is more skewed towards left side. So for right skew, mean is more than median. For left skew, mean less than median. Important MCQ question. Just remember to use your mind much now. Not much time is left. So for right skewed data, mean more than median. For left skewed data, mean is less than median. Okay. Now types of study: cross-sectional study, snapshot. Snapshot means that the study which is occurring at a point of time. Like if you are going in a OPD, and in OPD at that point of time you are taking data from a particular group of patients and you are not following that patient for any further follow-ups, or neither you are going in the retrospective direction, so that is cross-sectional study. Case control is retrospective study. Okay, the event has occurred and now you are going retrospectively. So this is case control. Cohort is prospective study, means moving forward. Moving forward. Cohort is prospective study. You are including a group of patients which is known as cohort, and you are now starting taking the values and parameters for that particular patient. So that is prospective study. RCT, randomized control trial, is the gold standard method for research studies. Okay. So which is gold standard? RCT, which is prospective, cohort, retrospective, case control, and cross-sectional is snapshot. Every point is MCQ question. Now bias, examples of bias: selection bias, wrong sampling, recall bias, case control studies. Recall bias is common in case control studies because why? What recall? You are doing retrospective, so you have to recall the patients, you have to recall the events. And observer bias in measurement error. Association measures relative risk and odds ratio. These are the two measurement of association. So relative risk, how it is calculated, this is very important. MCQ can be asked, numerical questions can be asked. Relative risk is incidence in exposed upon incidence in unexposed. Okay, this is relative risk. It is RR. Odds ratio, odds ratio is odds of exposed upon odds of unexposed. Okay, so odds ratio and relative risk. In case control studies, we take odds ratio, and cohort studies, we calculate relative risk. So each and every point is important. MCQs have been asked in previous year NEET PG questions. So case control, odds ratio, cohort, relative risk is calculated, and these are the formulas of relative risk and odds ratio. Now screening test, some formulas for sensitivity, very important. True positive upon true positive plus false negative. So Just a trick to remember, if you can, sensitivity initially n is coming, so you have to do opposite of n. Opposite of n means n stands for negative, opposite of n is positive. So more positive should come in this formula. So in numerator also P, denominator to P, true P, start with true, truth is always first, so true positive upon true positive, just opposite of that, opposite of true is false and opposite of positive is negative. This is the way to remember. Now for specificity, P is coming first, so opposite of P and truth always comes first, so upper part numerator is true, negative, and then the same has to be written in numerator, and then opposite of this true, opposite is false, and opposite is P. So these are the formulas which have been asked hundreds of times in exams, so sensitivity and specificity. Now come for positive predictive value. Here also truth comes first, and here we are not doing opposite. Here P, so P, and upon same with TP, and we are doing opposite of only truth, that is false positive. And so PP, double P is coming, so everywhere PPP. Now negative predictive value, initially Tn upon Tn plus Fn. Okay, if two P are coming, then everywhere P is coming. If single P is coming here in negative predictive value, then everywhere N is coming. Okay, so this is the way to remember. You can remember in your own way. Okay, so interpretation, high sensitivity, we rule out things, high specificity, we rule in things. Okay, if the test is very highly sensitive, then it's we means sensitivity, what it is showing, true positivity. So we can rule out that particular disease with the sensitive test if it's coming negative. And high specificity, if the test is coming positive, then definitely that particular disease or event is occurring. Now errors, again MCQs have been asked. Just remember, don't use your mind now. Very much less time left. Type 1 error, false positives and represented by alpha. Type 2 error, false negative represented by beta. Okay. Type 1 error, false positive and alpha. Type 2 error, false negative and beta. Okay. Remember this. Now p-value, if p-value is more than 0.05, then it is significant and we reject the null hypothesis. Okay. Confidence interval, range where true value lies, narrow confidence interval, then precise result. If confidence interval crosses 1, then it is not significant. The statistical test, again important. Which test is used when? So t-test used when comparing means, two groups. If we are comparing means of two groups, like group 1, group 2, and there is mean plus minus standard deviation given of these two groups, and we are comparing, when t-test is used. ANOVA, when more than two groups, when group 3, group 4 is there and we are using mean or standard deviation, then with more than two groups, ANOVA. Chi-square test for categorical data, Fisher exact test for small samples, and Mann-Whitney test for non-parametric values. Now correlation, meaning of correlation, if +1 then perfectly positive, if 0 then no correlation, and -1 then perfectly negative. Okay, like sometimes we see parameters like homocysteine levels and HDL. So homocysteine level, or we can even take HbA1c levels. So HbA1c means diabetes, severity of diabetes. So if HbA1c is more, usually we see less HDL values. If HbA1c is less, we usually see more HDL values. So this is negative correlation. Okay. So in that manner, +1 for perfect positive, 0 for no correlation, and -1 for perfect negative. Now, correlations are two types: Pearson correlation for parametric values, Spearman correlation for non-parametric values. Regression predict dependent variables, example HbA1c versus lipids. Okay, so it predicts the HbA1c and lipids are dependent on each other. Now, graphs, bar graph is used in categorical values, histogram for continuous values, pie chart for proportional. A few MCQs on biostats. Which measure is least affected by extreme values? Mean, median, mode, or range. So median is least affected by extreme values. Mean is affected, mode is affected, and range is affected, but median is least affected by extreme values. In a normal distribution, mean equal to median equal to mode. We have already discussed. Standard deviation measures what it measures. Standard deviation measures dispersion of data. Okay, and 95% of values lies within +2 minus standard deviation and +3 standard deviation. 99.7% value lies, and plus minus 1 standard deviation, 68% value lies. This is important. Right skewed distribution, mean more than median more than mode. Left means mean less than median less than mode. So remember these signs for right, mode, mean, median, mode, and then greater than sign, and in this less than sign. Best measured for skewed data. Median is the best measurement for skewed data. Mode represents most frequent value. We've already discussed. We have taken the example of that. That one is coming 4 times, so that is mode. Okay, so most frequent value in a particular group of values is mode. Range is maximum to minimum. Variance is square of standard deviation. Okay, so variance equal to square root of square of standard deviation. Okay. Now, gold standard study, randomized control trial is the gold standard. Case control study gives odds ratio, and cohort studies give relative risk. This is important. Case control, odds ratio, relative risk, cohort study gives relative risk. Now, cross-sectional study measure, it measures the prevalence at a particular point of time. It's what we have read, snapshot type of study at a particular point of time. Recall bias common in case control study as it is retrospective, so recalling is difficult and it gives error sometimes. Prospective study, cohort is taken. A cohort, that is a group of people are taken, and then the study is conducted on them. So this prospective. Retrospective is case control. Incidence is measured in cohort. Selection bias occurs due to improper sampling. Confounding factor distorts the true association. Okay, uh, like the association of alcohol with deranged lipid profile. Okay, but alcohol is also alcoholics are doing smoking. So smoking is the confounding factor. That is, it distorts the true association because smoking is also causing deranged lipid profile. RR relative risk equal to 1 means no association. Odds ratio approximates risk, relative risk when disease is rare. This is important. Odd ratio approximates the relative risk when the disease is rare. Relative risk more than 1 indicates risk factor, less than 1 indicates protective factor. So RR equal to 1, no association, more than 1 is the risk factor, and less than 1 is the protective factor. Okay. Attributable risk shows excess risk due to exposure. Attributable risk shows excess risk due to particular exposure. Population attributable risk is the impact on population of that particular exposure. And the strongest association measure is the relative risk, which is the strongest important MCQ. Strongest association risk predictor is relative risk. Case control cannot measure incidence. Incidence is measured in cohort studies. Cohort cannot measure odds ratio directly, so it is less preferred. And odds ratio equal to 1 means no association. Sensitivity we have already discussed, true positive upon true positive plus false negative. Specificity we have already discussed, true negative upon true negative plus false positive. Positive predictive value we have already discussed, true positive upon true positive plus false positive. And negative predictive value, true negative upon true negative plus false negative. आप लोगों को लग रहा होगा बहुत इजी है ये सब, लेकिन sometimes in exams we even commit mistakes in the formula of these simple things. So high sensitive test rules out disease, and high specific test rules in disease. So the test is highly sensitive and it's coming negative, then it's ruling out that disease. If it's specific and it's coming positive, it's ruling in that disease. The screening test should have high sensitivity because we need to rule out the disease in screening test. Confirmatory test should have high specificity because we need to confirm the disease with that particular test. Positive predictive value increases with disease prevalence. Negative predictive value decreases with increased prevalence. Okay. False positive, false negatives. Fine. Best screening test example: HIV, ELISA. Best screening confirmatory test is Western blot. This is for HIV. Ideal test has 100% sensitivity plus specificity. They might ask this question. Ideal test means 100%, 100%, or 99.5 or 99.5. Sometimes we get confused, but the answer is 100%. Type 1 error, already discussed, false positive is denoted by alpha. Type 2 error is false negative, denoted by beta. P-value less than 0.05 means significant and null hypothesis is rejected. Confidence interval crossing 1 is not significant. Narrow confidence interval indicates precise estimate. Wide indicates less precision. So confidence interval, if it is narrow, then precise, and wide, then less precision. Power of study, how to calculate 1 minus beta, that is type 2 error, beta is type 2 error. So power of study is 1 minus beta. Increasing sample size increases power. Alpha error decreases with larger sample. Beta array decreases with increased power. As we have seen, the formula for power is 1 minus beta. So beta array decreases with increased power. Compare two means, t-test is used. More than two means, ANOVA test is used. Categorical data test, chi-square is used. Small sample categorical Fisher exact test is used. Non-parametric equivalent of t-test, again important. Mann-Whitney U-test, non-parametric equivalent of t-test. Correlation test, Pearson coefficient. Okay, non-parametric correlation is Spearman. So correlation, again remember, two types, Pearson and Spearman. Pearson and Spearman coefficient. So Pearson Spearman is non-parametric. Regression predicts outcome variables. Chi-square test requires expected frequency more than 5. Paired data uses paired t-test. Now, if true positivity is 80, true positive is 80 and false negative is 20, then sensitivity. Let's calculate here. Sensitivity is true positive upon true positive plus false negative. So true positive is 80 upon 80 plus 20 false negative, so it's coming 80 upon 100, which is 80%. Same way you can calculate specificity. Specificity is true negative upon true negative plus false positive. True negative is 90 and false positive is 10, to 90 plus 10. So here it's 90 by 100, which is 90%. Very easy calculation. RR formula, incidence exposed upon unexposed. Odds ratio formula, AD upon BC. And like this is the table, and A, B, C, and D. So odds ratio is AD upon BC. Prevalence formula, total cases upon population. Incidence formula is new cases upon population at risk. Mortality rate is deaths upon population. Case fatality rate is deaths upon cases. Attack rate is new cases upon exposed. Secondary attack rate excludes immune individuals. So these were the few important questions and few important topics from statistics. And statistics is an important topic for these MCQ exams. It's highly scoring, and believe it or not, sometimes the questions are very easy. These types of questions have been asked previously, and mostly calculations are very easy. And theoretical questions are asked like more than two means is compared by, they will give option t-test, ANOVA, chi-square, all none of the above, so you have to choose ANOVA. So these sort of questions they are asking. So don't worry much about stats. If you have read till now, that is fine. Revise that thing. If you have not read till now, then at least go through this video, and few of the questions can be solved from this video. Okay. So thank you very much, and all the best to all of you for your exam on 12th. And yesterday we have already discussed in our video that what should be the strategy for attempting the Pdcet exam, as per my opinion. So thank you very much for your patient listening, and all the very